In Unit 3, we'll start talking about the biochemistry of phages. In this unit, we will discuss the basics of the chemistry that you need to understand the complex molecules that make up bacteriophages and their bacterial hosts. These are the learning objectives for this unit. First, you should recognize the 6 most common elements in biological molecules. Identify the different types of chemical bonds and recognize their impact on biological molecules. Understand polarity and how it impacts hydrogen bonds and hydrophobic interactions. State, at least, and there are many of them, 4 important roles water has in biology. Describe the pH scale and what it represents chemically. Explain to a peer audience how enzymes work and 2 mechanisms of enzyme inhibition. And finally, and perhaps most importantly, you should recognize, understand, and be able to draw organic molecule structures. So the lecture for this unit will have 4 parts. In part 1, I'll talk about atoms and molecules. So as a way to start this discussion, I want to tell you about emergent properties. And emergent properties are properties of a system that aren't apparent in the individual building blocks of that system. So to give you an example of what that means, emergent properties are incredibly apparent in life because all of the life on Earth is made up of impossibly small individual building blocks of matter called atoms. And atoms then come together in many unique and interesting ways to form different molecules with unique chemical properties. The molecules then form incredibly complex structures called cells that then form tissues and organ systems that come together to make all of the interesting multicellular organisms like people and other life on the planet. People and other organisms form into populations and then into communities that have culture and unique behaviors. Then we all interact in ecosystems and in the entire biosphere of this incredible planet we live on. But all of these miracles of life are based fundamentally on the properties of these individual atoms and the way that they interact with each other. So let's talk about that chemistry. Here are some terms that you need to know about to understand chemistry. We'll talk about some of these in detail, and hopefully some of these are words that you've learned in some of your previous chemistry or biology classes. So we're going to talk about mass, and that is the matter that makes up chemicals. Some elements of mass include subatomic particles that make up atoms. And atoms come together to make up molecules. So molecules are collections of atoms that are bonded together. Molecules can interact with each other to form compounds. And also macromolecules, which are large molecules that are composed of distinct individual molecular components. So the way that those atoms interact to form molecules are called bonds, and we will talk about 3 different types of bonds in this lecture. We'll talk about covalent bonds, which can be both polar and nonpolar. We'll talk about ionic bonds and hydrogen bonds. We'll also talk about reactions. So reactions can include the way that different chemicals interact with each other. For example, the hydrophilic and hydrophobic interactions that different types of chemicals with different chemical properties have. We'll also talk about the pH of water and of buffers. And we'll talk about chemical reactions such as condensation and hydrolysis reactions. So during this lecture, we'll also talk about different ways that we have to represent molecules. So molecules are incredibly small. We have different ways that we learn about them. But in order to write them on our pages, we have to use models, which are often drawings or representations of what the molecules are actually like. So we have common names for a chemical called water. You're probably familiar with that term. We also have more complex formal chemical names. So water's formal chemical name is hydrogen oxide. We will also write the chemical formula, which is a shorthand that indicates the individual elements, the atoms that make up that chemical, and the numbers of those atoms in the molecule. For example, water is composed of 2 hydrogen atoms, so we have H2, and 1 oxygen atom, so it's H sub 2O. You can also write structural formulas. And structural formulas show those atoms as they're connected with bonds. And here we're representing some covalent bonds as solid lines between those hydrogen and oxygen atoms. We can also use structural models that indicate the relative size and shape of different atoms, like shown here in the middle. And also, we have different models for how atoms work and interact with each other. This is one model that we have for atoms. So this is not an entirely accurate representation of what an atom is like. This is a Bohr model of an atom. But the Bohr model is a useful way to understand many of the important properties of atoms. The Bohr model shows that the nucleus of an atom is composed of protons, which are positively charged subatomic particles, and neutrons, which are uncharged subatomic particles. Protons and neutrons both have a significant mass in terms of the atom. So the nucleus, which is composed of protons and neutrons, makes up most of the mass of the atom. The atom also has electrons, which are smaller subatomic particles with a negative charge. If the number of electrons in an atom equals the number of protons, then the negative and positive charges combine to make that atom neutrally charged. However, electrons orbit the nucleus. They're more loosely associated with the atom than the nucleus itself. They orbit in the Bohr model in these electron shells. And atoms are able to gain and lose, in certain situations, electrons. And that changes the overall charge of the atom and occasionally the molecules that those atoms are associated with. We keep track of the different atoms, the different elements that make up all matter using the periodic table. This is an abbreviated version of the periodic table, which shows many of the first chemicals in the periods arranged in order. So the atoms on the periodic table are arranged by their chemical properties. And their chemical properties, as we'll talk about, are going to be determined by how electrons populate these shells that are associated with the nucleus. There are some other important aspects of the periodic table that you'll see here. So each atom has an atomic number. So helium is atomic number 2. And the atomic number is determined by the number of protons in an atom's nucleus. The elements also have an element symbol. So helium is He, while hydrogen is H. So that's the shorthand that we use to represent those atoms when we draw molecular structures. The atoms also have a mass. The mass is the average of all the different isotopes of an atom that we'll talk about in a minute. But the approximate mass of protons and neutrons in the atom is, or the approximate sum of protons and neutrons in an atom is equal to the atom's mass. So helium has 2 protons and 2 neutrons, and its average mass number is 4. In this periodic table, we also show the electron distribution diagram, which is not included on many periodic tables, but we'll talk about this in just a moment. One important concept with atoms is that the fundamental chemical properties of an atom is generally determined by the number of protons that make up the nucleus. So that gives an atom its atomic number. However, the same atomic number element can have different numbers of neutrons in the atom's nucleus. So that changes the overall mass of that particular atom. So the chemical properties of atoms with different numbers of neutrons are generally the same. And so we call these different massed elements isotopes. So isotopes are atoms with different atomic masses. So one interesting aspect of isotopes is that while the chemical properties, the way those atoms react with other atoms, are relatively the same, sometimes adding a certain number of neutrons to the nucleus of an atom can make that atom unstable so that it decays or breaks apart by giving off radioactive emissions. So you can see that carbon-12 that has six protons and 6 neutrons in the nucleus is a relatively stable compound. That is the most abundant form, the most abundant isotope of carbon. Carbon-13, which has 6 protons and 7 neutrons, has an atomic mass of 13. It is much more rare in nature than carbon-12, but it is also a stable isotope. Carbon-14, which has 6 protons and 8 neutrons, is an unstable isotope of carbon. Carbon-14 is radioactive, and it will emit radioactive energy as that atom decays into subatomic particles. So the 6 elements on the periodic table that you really need to know about are these that have the mnemonic CHONPS. So these are the elements of life. So carbon, which is atomic number 6, carbon forms the backbone of organic molecules. Hydrogen, which is atomic number 1, is the most abundant atom and is an important component of all organic molecules. Hydrogen, because it is the most abundant atom, will bond in organic structures with anything that's not bonded to another atom. Hydrogen is also important for acid-base chemistry. Oxygen, which is atomic number 8, oxygen is abundant in the atmosphere. It is also a very electronegative, so it likes to hang on to electrons. And it's also very chemically reactive, partially because of that electronegativity. Nitrogen, atomic number 7, forms several important structures of proteins and nucleic acids. There are keywords that we'll talk about for each one of these. Nitrogen is unique because it has a keyword that does not include nitro. Instead, amine, amide, and amino are keywords for chemicals that include nitrogen. Phosphorus, atomic number 15, is important because it forms the backbone of nucleic acids, and it also is an important component of phospholipids, which make up cellular membranes. Sulfur, which is atomic number 16, is less abundant than the other 5 elements. However, it is important in many amino acid side chains. So these are the most common elements in biology. And these are the 6 that you should recognize and know when you look at chemical diagrams. For example, this amino acid phenylalanine or this nucleic acid guanine. We have keywords that will be in those chemical names, for the formal chemical names for different chemicals. So you should recognize those. Carbo for things that include carbon, hydro, oxy, amine, that's the one for nitrogen, phosphor, and sulfide.